Yes, welcome students to this wonderful discussion on the assignment problem. Okay, so assignments problem. We know that we are assigning persons to the job or jobs to the persons or machines to the works or works to the machines uh, and where uh, the corresponding assignment tasks also will be given to us like this in this particular format. This type of problem we call it as assignment problems. Assignment problems. Our aim is to find out which, suppose these are the persons, these are the jobs, which person should be assigned to which jobs so that our total transportation cost is very minimum. Our assignment cost is so minimum. That is optimum. That is minimum among minimum. That's what our aim here. Now look at this. The first step in any assignment problem is that uh, actually this process of solving assignment problem is called an Hungarian method. In the Hungarian method, the first step is that we have to check whether the given problem is a balanced one, that is number of columns equals number of rows, or not. So if not, then we have to make it balanced, then we have to go further. Here it is a balanced. The second condition we have to check is whether the given problem is a restricted one. That means any persons cannot be assigned to any jobs or any jobs cannot be assigned to any persons. Then we say that the type of problem is called a restricted problem. Now look at this here. Um, both are satisfied. I mean, this is a balanced problem. Also, it is an unrestricted problem. Unrestricted problem. So our aim is that go for the second step. In the second step, what we do is that row reduction. Okay, row reduction. That's what we do. Row reduction. What do we mean by that? We are taking the first row, the least element we are finding out, then we are subtracting the least element from all other elements. Okay. Um, Look at this, the first row, the least element is 1. Subtract this one from this, from this, from this, the same row elements. 2 minus 1, 1, 1 minus 1, 0, and 5 minus 1, 4. The same things we have to do for this row as well as this row. So least number here is 1, subtract that 1 from 7, you will get 6. Least element is 1, subtract that's this 1 from 3, you will get 2, and 1 minus 1, you will get 0. The same thing we have to do for the last row also. The least element 1, subtract this 1 from this, 2 minus 1, 1, 1 minus 1, 0, 5 minus 1, 4. So row reduction over. Row reduction over. Now we have to do the column reduction. The same way, but instead of row, we are taking column. The first column, the least element is 1. Take that, subtract from all other elements. 1 minus 1, 0. 6 minus 1, 5. And 1 minus 1, 0. Now coming to the second column, the least number is 0. So 0 minus 0, 0. 2 minus 0, 2. And 0 minus 0, 0. Here the least element is 0. 4 minus 0, 4. 0 minus 0, 0. 4 minus 0, 4. So this is column reduction. Okay. So immediately after this, the next step that we have to draw the lines. Okay. Lines. How we have to draw the lines? Through maximum number of 0 occurring rows or columns. Okay. Maximum number of zeros occurring row or column we have to take, and we have to start with. Here the type of the matrix is 3 by 3, therefore the maximum 0 possible is maximum 0 possible are 3 zeros. So we are looking for 3 zeros, a row or column. First row, no, only 2 zeros are there. Second row, only 1 zero is there. Third row, 2 zeros are there. First column, only 2 zeros are there. Second column, only 2 zeros are there. And last column, only 1 zero is there. Next to that, number of maximum zeros are 2. 2 zeros occurring rows or columns we have to search for. Here, 2 zeros occurring. Draw the line across the row. So draw the line across the row. Second row consists of only one zero, so we cannot take that because no 2 zeros are there. The last row there are 2 zeros again occurring, so we can draw the line across the row. So across the row we are drawing the lines. Right. Once we strike out the 0, we should not take the 0 into account. So this 0 should not take into account. These zeros you should not take into account. So when you come to the column wise, there is no 2 zeros occurring because we have striked out this and this. No 2 zero occurring. No 2 zeros are occurring. Right. Now 2 zeros occurring, those are columns checked out. Now a single zero occurring rows or columns we have to search for. Here 2 zero occurring, already striked out. And here 1 zero occurring, we can strike out that. So make a line across the second row. Third row already staked out. Now count the number of lines we have drawn just now. How many lines? 1, 2, 3. This number of lines must be equal to the order of the matrix given to us. The number of lines drawn must be equal to the order of the matrix. If that is the case, optimum is reached. Optimum in the sense that minimum among minimum is reached. That stage is reached. The condition is satisfied. Okay, very important. Sometimes this number of lines may not be equal to the order of the matrix. So in that particular case, we have to go further. But here we are lucky to have number of lines equals the order of the matrix. So optimum is reached. The next step is that only 0 occurring cells we have to take. 0 occurring cells only we have to take. Non-zero occurring cells we should not take. This we should not take. Don't take this. Don't take this. Don't take this. Only 0 occurring cells. 0 occurring cells. This one, C11, C12, and C23, then C3132. So all these cells we are writing zeros. Only the 0 occurring cells we have to take into account. Then what? Then we have to do optimum assignment. What do we mean by that? We have to assign 0 such that each row and each column should have only 1 0. That means each person should have only one job. Okay, a single person should not have 2 jobs or 3 jobs. Each person should have one job. The same way, each job should be assigned to only one person. So what I am doing there, I am assigning this person to the job. Okay, then I cannot assign this because one person cannot be assigned to 2 job. Now here I cannot because the single job cannot be assigned to 2 persons. So once I assign this, I have to strike out this and I have to strike out this. Now I am coming to the second person. This person, only one option is that, so I am assigning there second person or B person to last job J3. Now last person, he's also having only one assignment because this has already been striked out. Here also striked out. So C person can be assigned to J2. So definitely this assignment, I mean the first person, A person to first job, second person B is to third job, and the third person to second job. So this definitely this assignment will give us uh, the optimum assignment cost for our problem. Optimum assignment cost for our problem. This assignment. How that comes, some techniques inside this course that makes this final assignment which gives us the least transportation cost. How to find the least transportation cost? See, A is assigned to the job A is assigned to the person A is assigned to first job, so 2 rupees. B is assigned to third job, 1 rupees, and C is assigned to second job, 1 rupees. So if we assign all these people to this job, the sum of the assignment cost will give us the total cost. So 2 plus 1 plus 1. So 2 plus 1 plus 1, 4 rupees. So I challenge you that we cannot make in any other assignment such that total cost goes less than this. Total assignment cost, I mean, goes less than that, less than this 4 rupees. It is impossible. And thus we get a very least, I mean, optimum transportation cost for our problem. So the optimum assignment is that first person to first job, second person to last job, third person to second job. If do so, the least among least, that is optimum transportation cost is rupees 4. So okay, so with that we are coming to the end of this discussion. In another discussion, I will take in another problem. We will discuss that. Thank you.